ThreatQ is a threat-centric security operations platform designed to fulfill a variety of use cases, including vulnerability management. The system collects threat intelligence data from a wide array of sources and is capable of ingesting data in any format. Amongst other technical indicators, vulnerability-related data such as CVEs, known exploits, related indicators, and reports of exploitation are stored and related to one another for context. Such information is pulled from the NIST National Vulnerability Database and other threat intelligence feeds that have applicable information available. ThreatQ helps to uncover the true severity score of CVEs by assessing each CVE against your environment. This is achieved with a scoring policy that helps to make all threat intelligence data more relevant to your organization and allows prioritization to take place. The ThreatQ scoring policy can be configured to consider the CVSS version 2 and CVSS version 3 scores, as well as the availability, integrity, and confidentiality metrics that come with the CVE on ingestion. Other criteria can also be added to consider the surrounding environment. For example, if you are a US retail organization and the only malware available to exploit a particular CVE is being reportedly used against Chinese critical infrastructure, it's probably not relevant to you. The end result of ThreatQ's scoring mechanism is an accurate score for the CVE and a wealth of related information on hand that will help the decision-making process when prioritizing the rollout of patches in the limited maintenance windows available. The ThreatQ threat library stores all the threat intelligence data that is collected. It is deduplicated, aggregated, and normalized for ease of use. Here you can see an example of a CVE stored within the threat library, which is scored 10 based on the scoring policy. Information on this particular CVE has been collected from 3 different sources, including the National Vulnerability Database. Attributes are used to hold the information about the CVE. This includes things like which software versions are vulnerable and also the original CVSS scores that came with the CVE itself. Other information available includes things like a description of the CVE, information about adversaries that are known to try and exploit or may have successfully exploited this particular vulnerability, related files which give you more information and context about the vulnerability, and also some related indicators. Note in this case there are a number of MD5 and SHA-256 hashes which could be used to perform threat hunting across your organization to understand whether or not you may have been compromised. All the information that is available on this screen can be exported into a report and then shared amongst other teams. ThreatQ's Open API allows for clever integrations with other security tools in the environment to help streamline the workflow of security teams. Such example is this operation which allows for the vulnerability management system to be quickly checked to see if this particular CVE is present on any systems in the environment. ThreatQ submits a real-time query to the API of the vulnerability management tool and retrieves the results of its latest scan. In this case, you note that there are several systems in the environment that require patching. ThreatQ Investigations provides the industry's first cyber situation room. Using this visual tool, you will see relationships between the vulnerability of interest and other threat intelligence data collected by ThreatQ. Here you can see the same CVE previously shown. We can add relevant attributes of interest to the investigation, along with other information such as the related files, adversaries, and indicators. Using this tool, we can build out a picture to gain a better understanding of the CVE by exploring things such as its relationship to an adversary group. We look at the various different tactics and techniques that these groups use, along with other indicators that have scored highly within the platform to get a better understanding of what we need to be on the lookout for within our own network. Here we can see an example of where ThreatQ Investigations has been used to identify vulnerabilities within the environment that require urgent patching. Through integrations with the SIM and network IPS, ThreatQ has been notified of the sighting of highly scored indicators. One of these indicators, an MD5 hash, has been related to a CVE, as you can see here. The overall conclusion we gain from this investigation is that the adversary group APT28 appears to be trying to infiltrate the network via a couple of different avenues with the ultimate goal of exploiting this particular CVE. So what we want to do is again understand, is this CVE actually present within the environment? So we again run an operation to query the vulnerability management system to understand whether or not there are vulnerable hosts in the environment. And this time we see that there are 4 of those. So what we want to then do is create a task within the system to get the vulnerability patching team to go and patch this particular CVE. So I put in a description, make it a high priority task, as we can see active attempts to exploit this, and assign it to the patching team. We save that in the system. So we get that task here that's now related to that particular vulnerability. So what we can also do whilst we're waiting for that particular patch to be deployed, we can go and have a look at the other things that we know about this particular adversary group to gain an understanding of the various different attack patterns and techniques that they use, and look at the mitigation strategies that we can put in place to further protect ourselves against their attacks.